Hey, feeling good, like I should. When in dark, I walk around the neighborhood, feeling blessed.
All right, let's take a look at our homework for lesson 6.2.5, starting with problem number 92. It says, sketch the two similar triangles at the right on your own piece of paper and find the scale factor. Okay, so remember, finding the scale factor, we are going to highlight the what am I looking for? The corresponding sides. So the 6 corresponds with the 18, the 8 corresponds with the x, and the y corresponds with the 30. So it's going to be the 8 and the 16, which are going to define our scale factor. So what do you multiply times 6 to give you 18? You multiply 3, right? Well, that's pretty straightforward. Remember, you could have just taken the ratios and then simplified them, and then you could either use 3 over 1 or 1 over 3, depending on which direction you're going. And that'll actually come in handy for this one, because one of the times we're going to go and make it bigger, so we'll use the 3 over 1, and the other time we're going to make it smaller, so we'll use the 1/3. So to solve for x, we have to take 8 and multiply it times the scale factor that's going to make it grow. So that would be 3, so that's going to be equal to 24 millimeters. And then to solve for y, we're going to make it smaller, so we're going to take 30 and multiply it times the scale factor that's going to shrink it, which would be the 1/3. And so that becomes 30 over 3, which is equal to 10 millimeters. So y has to be equal to 10, and x has to be equal to 24. Alex and Maria were trying to find the side labeled x in problem number 92. Their work is shown below. I noticed that when I multiplied by 3, the sides of the triangle got bigger. Yes, that is the scale factor 3. And then Maria says, I remember that when we were dilating shapes in lesson 6.2.2, my shape got bigger when I divided by 1/3. Well, okay. Wonderful. Dividing by fraction is so much easier than multiplying, and if she had actually completed this process, she would have seen that she was multiplying times 3. So yeah, dividing by 1/3 is the same as multiplying by 3. Consider these two equations, y equals 3x minus 2 and y equals 4 plus 3x. Graph them both. Notice how there's no solution because they're parallel to each other. That's because they both have the same slope. If we rewrote this, remember, y equals mx plus b is what we call slope-intercept form. If we rearrange these guys, it becomes y equals 3x plus 4. So they have the same slope but different y-intercepts. That means that they are going to be parallel lines. And parallel lines never intersect each other. Therefore, these will never have a common solution. So there's no solution. Holly shocks are, why are we so into box plots these days? There must be, chapter 7's coming up, and this is the chapter where we do a little bit of data statistics, but not a lot of box plots. That's kind of weird. But anyway, we never want to forget it, so let's just practice it. Hollyhocks are tall, slender, flowering plants that grow in many areas of the U.S. Here are the heights of hollyhocks that are growing in a park. And so it looks like these are already in order from least to greatest. That is wonderful news because we have to order our data in order to find everything that we need for our box plots. So we will recognize that there is a minimum, which is 10. There is a maximum, which is 52. The median is the number in the middle. And how many do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I like the number 11. It's an odd number, which means the number that's in the middle is going to be a single number. So half of 11 is around 6. So let's go 1, 2, 3, 4, 5. This should be the middle number right there. 1, 2, 3, 4, 5. Yes, 5 above, 5 below. That means that the median is 47. Now we have to take everything below the median to find the lower quartile. That's going to be the lower quartile, or sometimes called quartile number 1. And then the median of the upper data is going to be the upper quartile, which is sometimes called the third quartile, which would be 49. So to create the box plot that we have to do for C, we have to identify where's the minimum on this number line and then plot that point below it. Where's the maximum on the number line? Then we plot the point below it. Where's the median? 47 is right around here. And the lower quartile would be 43, and the upper quartile would be 49. So we don't plot these points literally on the number line. The number line is just above the box plot or below the box plot as a reference point. But we would plot all of these below it, and then the 3 here, dots there, just turn that into that interquartile range box, and you've got your box plot. So it looks like this guy's an outlier. Clearly, look how big that's 25%. 1/4 of all these numbers are less than 43. And one of them is really close to 43. The other one's nowhere near it. So when you've got this much of a spread in your box plot, that sort of indicates that there is an outlier in there. Use the graph at the right, add points to the table below, and then write the rule. Okay, so we know that the y-intercept is at 6. There's the y-intercept right there. And it looks like it goes down 1, 2, 3, 4 for every 2 that it goes to the right. So that is -4/2, means that the slope ratio is going to be -2. So if slope ratio is -2, the y-intercept is at 6, there is your rule. And now it's just a matter of identifying each one of those points and plugging those into the table. It says, explain how to use the table to predict the value of y when x is equal to -8. How to use the table? Well, you'd probably want to have every number accounted for and not be skipping any of them. But you could go 2, 3, 4, 5 would end up having to be -4. 6 is -6. 7 would be -8, and 8 would be -10. So you can go this direction, and then you'd have to do the exact same thing in the other direction. So you just keep counting and adding by 2s until eventually you got there. Just extend the pattern. Use these following directions to create a mystery letter. On a piece of paper, draw basically a coordinate grid, and then scale each axis from 6 to -6, and then plot these points and connect them in order to create a rectangle. So 2, 1, 2, 4, 3, 4, and 3, 1 are all where? Right here. That's the original? No, it's not the original. The original is the rectangle that looks like this. That's the original. Or something to that sort. Maybe this is the original right there. There we go. That's it. And then it says rotate it 90 degrees clockwise, so it's going to go this way. And the pivot point is at 2, 1, so there's the pivot point. So this point comes down to here, and these guys follow, and so this is the answer to A. Then reflect the new rectangle over y is equal to 2. So this is the line where y is equal to 2, so it's going to form a reflection to here, and that is B. And remember, this was the original, so we have ourselves the letter C that is created from that. And that is it. All right. That was nice and quick. How much time did we take? Not even 10 minutes. Good job. All right. Let's move on to the next activity. Take care. Bye. Bye.
Hey, feeling good, like I should. When in dark, I walk around the neighborhood.